Let's go through LeetCode 2507, smallest value after replacing with sum of prime factors. So this question is that we are continuously doing these kind of operations. That is, for example, if there is an n, we get all of its prime. For example, prime factors. For example, 15, right? 15 can be read as 3 multiplied by 5. 3 is prime and 5 is prime. Then for this kind of 3 and 5, we sum it up to 8. And for 8, right? It can be right as 2 multiplied by 2. So we sum up to 6. And 6 can be right as 2 and 3, right? So 2 plus 3 equals 5. And return the smallest value n, right? So the reason is that we are not keeping. The reason is that, for example, we have 4, right? 4 equals 2 plus 2, right? And multiple by 2, right? And then sum them up, still be 4, right? So if that is 4, right? So the question is asked that as long as this data is smallest, is not going to decreasing, then we stop. It's not asking us the final result is a prime, because doing like this will not get a prime number, right? So let's return the smallest number. So just based on what the question asks, we just write the code based on simulate, right? So it will be kind of straightforward. So what we do is that in Java we can write this int v, for example, equals let's have a big number, right? 1 0 0 0 1, okay. So we'll say while v equals, we'll have function get result, okay, n, while this one is smaller than n, right? You will have n equals v, right? Why we use another variable here is that someone may like to write this, right? So while get result n smaller than n, then we'll have n equals 3 get a result, right? These do calculation twice, right? So it's not efficient as we add another variable, because we calculate get a result twice. So we introduce another variables called v, and while this one equals this smaller than n equals v. So it's just calculate once, right? In the end, we just return n, right? So when we jump out of the while loop, that means this get result will not get smaller anymore, right? So we have a private int get result, right? Int n. So what we do is that we have int result equals to 0, right? And for int I equals to 2, I smaller equal to n, I plus plus. Let's say while this n is greater than 0 and n mod I equals 0, right? So we'll have this kind of n mod equal to dy equal to I, right? So how are we going to handle this kind of factors, right? So that is just a result plus equal to I, and in the end, return result. So this is Java code for this. Okay. Let's change this one to Python, right? Python code will be similar, right? So the thing is that we'll write here. Python we can write something like this. While v comma equal to get a result and smaller than n, right? Doing something. So in Python, we can introduce a variable use v comma equal to, right? Then we'll have v equals to n equals to v, right? And then just return n. So we need to write get a result n, right? df get a result and n, it is an integer, right? To also return an integer. So what we do is that we have result, right? Result equals to 0, while n greater than 0, and a mod I. Oh, let's say for should have for loop, right? For I in range I range 2 to n plus 1, right? Let's say while n greater than 0 and n mod I equals to 0. In this case, we'll keep dividing n mod equal to divide equal to I, right? So for this case, double slash or slash is the same because n mod I equals to 0, right? So in this case, result I equal to I. And what we do is that return result, right? This one, n equals v, while v equals get result n. While plus result equals to 0 in range 2, while this one result plus equal to we should have this, right? Sorry, we should have this. Should be this, right? The brackets should be here. Let's try and see if we don't have with brackets, whether it be fine. I think we should have these brackets. That means in Python, I think this is a feature after 3.8. We can use the brackets and define v comma equal to.